Welcome to EDU World Space.
So in this video, we're going to talk about question 42 from chapter 20, which says, in addition to CO2, two additional stable oxides of carbon form. The space-filling models for CO2 and the other two stable oxides are shown below. What are the formulas for the two additional stable oxides of carbon? Explain the bonding in each of these two forms using the localized electron model. So we have three different space-filling models. And we know that one of those is CO2. So we can go ahead and assume that's the one in the middle, which has one black atom and two red atoms. So this is CO2. So that must mean that our carbon atoms are in black and our oxygen atoms are in red. So that would make this first space-filling model for carbon monoxide, CO. And our second space-filling model would be for dicarbon trioxide, which is also known as carbon suboxide. But it would have a formula of C2O3. So our other two stable oxides of carbon are CO and C2O3, carbon monoxide and dicarbon trioxide. So let's talk about the bonding in each of these. So we know that when we bond our carbon and oxygen together, our carbon brings 4 valence electrons and our oxygen brings 6 valence electrons. So we have 10 electrons total. So the easiest way for both carbon and oxygen to have an octet in carbon monoxide would be for a triple bond to be formed. That way, both carbon and oxygen have all 6 electrons from their shared covalent bond, plus the 2 electrons in their lone pair, giving them a full octet. So the structure of carbon monoxide is carbon triple bonded to oxygen. And it turns out the other two molecules are also linear. So we have the structure of carbon dioxide, where carbon is double bonded to both of the oxygen atoms in a linear structure. And so carbon has 4 electrons from its 2 double bonds, has 8 electrons from its 2 double bonds, so it has a full octet. And each oxygen atom has 4 electrons from their double bonds, plus 2 lone pairs of electrons, which also gives them an octet. So the most stable structure for this is a linear double bond. And then we have the structure of C3O2, which is pretty similar to the structure of CO2. It's just that you have 2 additional carbon atoms in your linear chain. So rather than just carbon double bonded to 2 oxygens, you have a chain of carbons double bonded to 2 oxygens.